Here we go. We're here.
I feel like I have been nowhere until right now when we're finally here.
When you're here, you're at home. Containers from the couch.
I mean, literally.
But yeah, okay, that is true. Literally everyone is home. At least the three of us would confirm that. So, hey everybody, welcome. Welcome back to Containers from the Couch. I'm just going to go ahead and say it. This is Kubeflow week. I'm calling it out as it is. We have had Peter with us for the past 2 days, 3 including today, where we've been walking through Kubeflow. And we've done honestly some really impressive stuff. And basically we got to deploy a machine learning, or we built a model, right? We ran inference against that model. We had a Jupyter notebook. We built the Kubeflow dashboard. And of course, we installed Kubeflow on a cluster, which is, I went in reverse order there.
You did. That's impressive. Never mind.
My brain is not normal.
Apparently not.
So anyways, which has been really cool so far. And Peter's walked us through that and really gone into some good detail on all of these components. And so today, I think, we're going to go even a step further. We're going to look at Kubeflow fairing, quite possibly deploy a pipeline. Not sure, Peter. See how we're feeling on that and see where time takes us.
We also left off yesterday when last we met. We were about to see inference at work, right? We had deployed the endpoint, but we were waiting on something, so we ran out of time. So we need to, see how that turned out.
We need to run some inference, right? Okay, so I lied. We didn't run inference. We built the model and we deployed it. We did not run inference against it. So that's what we're going to do first.
It's not a lie. We ran it. We just didn't show you. We didn't check it.
We didn't see the output.
Exactly.
Exactly.
So we'll do that. It's not gonna take long. I'll hop on and I'll share my screen. But we'll do that, and then we'll focus on fairing for today because it is a complex chapter. We're not going to be doing pipeline because that is another complex chapter that is going to require the entire hour. So
nice. We'll save that for next week. We'll continue Kubeflowing into next week.
Kubeflow from the couch. Yes.
Like it?
Yeah. So you're not sharing your screen yet, Peter.
Okay.
But I'm sure you will be in the next minute.
It'll help.
It'll help. And so while we wait, Brent, we've been back to back today. We just came from a tech talk.
Yeah.
And now we're here. We're evangelizing all across the globe here.
I know. My commute has been like crazy today. So all right, let's kick this couch out of the way and let's get going. Dive right in. Inference. That sounds like a good place to start.
Yeah. So we did these 4 chapters like we were discussing, and we're going to do the inference at the final portion of inference. Just to walk you through, so we built the model, going through the model training chapter. And once the model was created, we stored that in an S3 bucket, right? So now, after that, we've created an inference. So once you have a model, you want to create an inference endpoint, which is you're essentially putting your model that you've created to the world so that you can, you serve your purpose, right? So people can start sending data and hitting the endpoint and start making predictions. So we created this endpoint, and then once you have an endpoint, we expose that using kubectl port forward, using a certain port, and then if you need to go and make predictions, you do need to have the required libraries. So we do need to install TensorFlow because we need to communicate the same language, right? So we need to install TensorFlow. This is where we stopped yesterday. So I'm going to go back here. I'll go to, is this visible? Is this
Yep.
here?
We're up. We see your desktop.
It looks good until someone complains about it. So
that's right. No one Slack Peter anything embarrassing right now.
Oh yeah, Peter closed Slack. Yeah, he did. Good. Oh, we love Slack.
So before that, I'm going to go and copy the dashboard link here really quick because we do need the dashboard up. I'll copy this one. Okay, so that's going to give us access to the dashboard.
And are we? So we are running our inference pod right now.
Yeah, well, I'll go ahead and check that. So I'll show. So this is the Kubeflow dashboard. So we go. We can close this one, and I'm going to follow some of the improvements that you guys suggested, which is really cool.
Uh-oh. Yeah. I had this problem earlier. When Richard Boyd was here, I was yelling, Richard, why? Yeah, you're trying to, that's.
Anyway, let me see if I can make through the day using that cursor there.
Go up higher, I think, maybe. If you go a little, no, okay. Yeah.
Oh, there you go. Awesome.
Yeah.
All right. Nice. So now let's go and see our pods that are running. So we have two parts. One is training, which are completed, and the other one is inference pod, right? So those are the two things. So in order to hit the inference, we do need to expose the inference endpoint. So remember, we use port forward, so we do need to do that because after yesterday, Cloud9 shuts down, all the port forward shuts down as well. So let's go ahead and do that.
Help me recap real quick or reset a little bit my understanding. So when you're doing machine learning, you train the model, and that's the job that you showed us that ran, and it had completed, and we saw that. Mm-hmm. And then the second thing that you would do would be what we're about to do, or what we've done, where we start the inference endpoint. And that's where it's using the model that we've trained to be able to do whatever it is we trained it to do. In our case, it's identifying, what are we identifying? Some pictures of something?
Yeah, so in our case, what we will do once we have, so we've got the inference endpoint available, which means we have an endpoint where we can start making predictions. Think of like an API, you're going to send an API request, and you'll get a response, right? So we've stood up the API endpoint right now for the model. Now what we need to do is we need to send requests to it, right? So if you are familiar with Postman, when you do API requests, similar type of concept here.
And what are we expecting this model to do for us, though?
Yeah,
remind us of that.
Yeah, I'll share that. So the expectation is the model that we created is from a fashionist database, a data set, right? Publicly available data set, and it has around 60,000 fashion icons, like a shirt, belt, those type of things.
Okay.
And we created a model using those images. When we do when we send predictions against it, we'll send a sample data, a sample image out of this data set and compare it, right? So And then the AI or the machine learning, the inference endpoint is going to respond to us and say that it thinks the image that you sent a request to is a belt. And that's what we are expecting to see here.
That'll be cool.
Yeah. All right. So what we'll do, we'll just make sure that our packages got installed, because that is where we stopped yesterday. And it should quickly come up and say these are all successfully installed, right?
Yep.
Now we're going to do the actual inference, which is essentially we're saying we're pulling another. So this is the inference client. So we're using a client in order to make the request. And we're hitting that endpoint that we just did a port forward to, right? This is where our inference endpoint is.
Gotcha.
Once we do this, okay. So ignore all the other gibberish. That is all TensorFlow stuff. So this is the expected outcome, right? So you see that it's data, it's got some signature, and then the model thought this was a shirt. So and it was essentially comparing shirt to shirt, and then it was actually a shirt. So that was the expected outcome. If we run another one, we should see a different output, right? So now it's saying, the model type was a sandal, and the actually it's a sandal. So it's a text way of validating. But if you imagine,
so the client is apparently grabbing an image of an item that it technically already knows what it is, passing it to the endpoint, and then the endpoint is identifying it, and the client is saying, "Yep, you're right."
Yeah.
Is that basically what I'm seeing here?
Yeah. Okay. So if you imagine, cool. If you have a website which makes predictions, I think we spoke about that yesterday. If you have a model that is created that has a list of dogs, right? And if you upload a picture of a dog, then it can say with prediction that this image is a dog and the type of dog, right? So that it's a similar type of, but doing it in a text way.
Yeah.
Okay. So that was that. That was pretty much how to do training and inference. We'll go ahead and delete, because we're not going to be needing these anymore. We'll delete the assets that we created. Okay. And we'll go right into fairing.
Okay.
Yeah, and that was cool. Just to highlight, we went through the training. Obviously, your data sets are large, but one thing Brent had pointed out yesterday, the day before, that's just really cool here is our actual inference object it was like 150 kilobytes, right? And this is running in a container on our Kubernetes cluster on regular old nodes, like nothing crazy. So just obviously there are more advanced use cases where it would be different, but just really cool to see that we did all this training yesterday. We trained the model, we deployed our model, and then boom, we're able to run it against in our Kubernetes cluster and test live. That was really cool.
Yeah.
Yep. So fairing is a feature of Kubeflow, and it sits right next to the capabilities, like we spoke about Jupyter Notebook in order to author your machine learning algorithms, and then fairing and Kubeflow pipeline. So if we go back here, you'll see those capabilities, right? So there's Katib for hyperparameter tuning. We don't see fairing here because it's essentially built into Kubeflow. There is no console feature for this one. But let me tell you what this does. So this bridges the gap between a developer who starts writing algorithms on their laptop using a notebook, like Jupyter Notebook. You can install that on your laptop as well. There's Jupyter Lab, so there's several ways to have access to a notebook. So you write an algorithm, you test it, and you know that the model is built. Now, if you want to take an approach where you want to go and push it into a dev platform, or you want to capture what you did and push it into production, God forbid, if that might be a model that your organization would enable, which I wouldn't.
Eventually, you might expect that something's going to go all the way into production.
Yeah,
But
eventually.
probably
Yeah.
not directly like you're suggesting here. But
Yeah. Yeah. So yeah, I wouldn't encourage you to go push to production directly from your laptop. You do want to make sure that you're taking proper precautions. Version control them. Somebody's approving the PR and all of that. But what this does is it short circuits your process that we saw earlier, where you build a model using a Jupyter notebook, you write an algorithm there. You can capture that as a container. So there's an API within Fairing which will go and capture everything, your environment variables that you've declared within your notebook, your application, the Python algorithm that you've written. They'll package all of that, capture, push it into a container, a Docker container. In this case, because we're using AWS, we've written plugins so that it gets captured into ECR, and we'll see it in action. And then you also have an ability to go and push it into an environment where you serve that model as an endpoint. So this chapter has 2 notebooks, and we'll go through that as we navigate this tutorial.
So it sounds like to me, Fairing is a process that's built in to Kubeflow that allows you to essentially set up the Jupyter notebooks and all of its requirements so that it can run basically the same way everywhere. Is that fair to say?
Yeah. Reproducibility, easily you can reproduce it. Version control, so all the work that you've done, it doesn't get lost, so you can capture that as a Docker container.
Okay, that's really cool.
Yeah. So in order to do that, we're going to do some prerequisites. As you can imagine, you're going to be talking to other AWS services. We need to enable permissions. In this case, we're going to use worker node IAM policy. So, quick note here, the goal is to use IAM role for service account so you don't have to go and plug in a policy to a worker node. But, there are some dependencies that we still need to solve. Until then, use this approach. Okay.
Yeah. And part of that, I think you mentioned the other day, is the reliance on an older version of the SDK that's built into some of the Docker images. So we need to get those revved, and then we can have the newer version of the SDK built in, and then we can switch to IAM role for service account. So we're working towards that, folks. If you're watching this in the future, we may have fixed this already. So definitely, double check this section to see how things align for you, in your present time. But today, as it stands, we're going to do IAM roles for service, we're going to do IAM roles for the instances.
Yep. So what we're doing here is we're attaching 2 IAM policies. One is ECR and S3, giving it permission so that you can do your work. So I'm going to run those 2 policies. So my worker node is, let me just make sure it got attached.
And by the way, hi from Amsterdam. Hello.
Nice.
Welcome, Amsterdam, in the house.
I love Amsterdam.
It's one of those places I want to go to one day.
You'd have to get on an airplane to get there.
I know, and obviously, Brent, you know how I feel about that, but one day. Anyways, go on. Sorry.
No worries. I don't think anybody is accepting.
Adam was anti-airplane before 2020, so.
Oh, really?
Statement.
Oh yeah. It takes a lot to. He's like B.A. Baracus from the A-Team when it comes to flying. He's like, you got to club him over the head and knock him out to get him on an airplane.
This is the key. Either that or just some really good drugs to put me to sleep, and then I just magically wake up and I'm there. I'm good.
Okay.
Yeah, I have mental problems. Thank you. I need help.
Yeah, you're not alone. There was another colleague that I used to work with here at Amazon, and he had that issue as well.
Yeah,
and one flight, he sat right behind me, and man, that was a flight to remember.
I think quick funny story, and then we'll get back to this. I'm pretty sure on one flight, it was a really choppy flight. It was one of those smaller planes with the 2x2. That's a small plane for me when there's 2x2.
That's a small plane for anybody.
I was sitting next to my coworker at the time. We worked at a startup. We had to go to Texas for something. And I remember he was laughing at me because I was like holding on to the thing, the sides, and I was looking at him like, please make this stop. Anyway, Michael, if you're out there, I'm sorry for doing that to you on the plane. It was embarrassing.
And he started trimming his fingernails right after that. So no more.
Exactly.
No more claw marks in your arm.
Pretty sure I did grab his arm at some point out of just pure fear. Okay, back to Jupyter Notebooks.
Let's do this one. So for fairing exercise and for the other chapters that we have, we're going to use another notebook. So this notebook is not going to work. This is, if you remember, I think it was the first day we created a stock TensorFlow in Docker container. Use that Docker container, and we created a notebook server. We're going to use an optimized version, which is this one. So make sure you copy that and then go to your notebook server and create a new one.
But look how easy it is to do that.
Yep.
Yeah.
So you go plug in the custom image. It is an ACR-based image. There's going to be an improvement in the near future. So Kubeflow 1.1 is about to get released. You're actually in the release phase right now. And it's going to bring in more improvements. Like we spoke about, 1.0 had multi-tenancy support, but that was only available for Jupyter Notebook. So now multi-tenancy is going to be enabled for Kubeflow pipeline as well, which is really good.
Nice.
And we're making improvements from AWS end as well. And a part of that improvement, we will have that image that we just copy pasted as a custom image. It's going to show up here. So
nice.
It's going to
be future audience. If you're watching this from the future, you might not have to copy and paste that image name. It might be there in the drop down for you.
Right on.
Welcome to the future.
So we're going to give it a name. We will call it EKSWorkshop. So make sure you copy this image, and we'll give it same like what we did earlier. We'll give it one whole CPU so that it's a little bit faster. And that's it. We'll go ahead and click on launch. And like we discussed, it creates a stateful set, right? Which has a different type of method that Kubernetes uses. Stateful sets are treated special in Kubernetes land, in terms of maintaining, keep it running as a pod, and then how it does updates. It follows a peculiar way of handling these stateful sets. So this notebook is going to be launched as a stateful set. Let's go back here and review what our next step is. So we just did this. Okay, so the next step is once we have our notebook server, we will go and clone or run this command, which will clone a repository.
Yeah, we can go ahead and do that. We don't have to wait, right?
Yeah. So this one we do have to run it from this notebook server.
Oh, from inside the server. Okay.
Yeah. Yeah, and I'll tell you why. We just need to wait until it finishes.
Oh, that's suspense is killing me.
So the reason, let me just go and tell you why. So the reason is because we have sample machine learning notebooks that are written in this repository. So if you go open up this URL, so you'll see there's in your docs, there's notebooks. So click on notebooks, and you'll see there's a bunch of,
nice.
We've organized it. So the first thing we're going to do is we'll go into fairing, and then we'll run this introduction Jupyter notebook, right? So this gives us a nice way to keep iterating all the sample notebooks that we want to add, and we can easily pull that into EKSWorkshop. Try it, test it, understand it, learn it, and then once you're done, you just tear down the environment.
Yeah, that's really cool to be able to have that kind of functionality and stitch all these things together so easily.
Yeah. So this environment is ready. So let's go connect to it. And I'm just going to pull in a Python 3 for now because we just need to run the simple command. It's cloning. So because we're running Linux, if you put an exclamation there, it can run git command there. So this is pretty much it. We're just going to close this. We don't need that anymore. We'll go back to our notebook environment. So you'll see that's the repository that we just cloned, right? We can actually shut this down. We don't need that. So now if you open it, you'll see notebooks and fairing. And here's the notebooks that we have got organized, right? So these are sample notebooks. So for this exercise, what we will do is we will run the fairing introduction, the first one. I do have a notification here saying, starting from here, it's okay to just focus on the Jupyter notebook because all of the information is captured here. You don't have to come back to the workshop in order to read the instructions because we rely on the process that has already been, because you can write instructions here, right? So all of that information is captured here. So please do read these. In terms of workshop, what we do provide is the expected outcomes, right? This is what you would see if you run this cell, right? So we do cover those. So if you feel like you can come back to these as well.
That's handy.
Yeah. All right. So let's go. You talk about what fairing is, and you already covered that earlier. So let's go and run these cells. Like I said, you can click on run here in order to run that cell. Or you can do Shift Enter.
That's neat.
As well. And the first thing it's going to do is it will install Kubeflow fairing. It's got some Azure storage components that are available over there as well. And once we do pip show fairing, it will show you the type of the version that is installed, all of that, right? So, so this is good. So we've got Kubeflow fairing installed. Now let's go and run the next series of cells, and I'll tell you what we are doing here once we go ahead and run them.
Shift Enter.
Shift Enter. Yep.
I'm learning.
Like an algorithm.
Lots of training.
That's right.
Lots of failures.
So, the way you'll know whether it's running or finished is, you'll get a number here, or else it will show as a star.
And the star means it's running, and the number means it's finished?
Yep.
Cool.
Yeah, so here with this one, I think this is a linear regression, if I'm not wrong. Yeah, so there's some good explanation here. So it's a linear regression model. We create a model based on that. If you're a person who understands linear regression, this should be easy for you. For me, what I look for is the number of epochs that it's going to run in order to create these models, so that I know that once I click enter, it's going to run those. And then what should be the output, right? So what should be the expected outcome? So in this case, it should show weight and it should show bias. So that's what we're going to see once we hit this. So let's go ahead and do train. And right now it's running those epochs, which is essentially
loops.
Like how many times you want to run your training. Okay, so that's the expected outcome. So it shows, weight is 0.96, and then bias is 0.21. So that tells us the algorithm that was available here is able to run. So now let's look at next step. So what we did here so far is we took the algorithm that was written on Jupyter Notebook and we just ran it locally, right? Now what we'll do is we will take the work that we had written, which is essentially the algorithm itself, right? And then things that we installed, the libraries, packages like Kubeflow fairing, these were the things that we installed. So we'll capture all of that, and then we will push it as a Docker container. In order to push it as a Docker container, we do have to create a repository on ECR, right? So here we tell, I'm using US West 2, and I'm going to authenticate with ECR. So let's go ahead and do that. Get a prompt saying login succeeded. Now let's go and create a repository. We're going to name our repository as fairing job. So that's my repository. Now, if I run the next command, that will do what fairing is going to do, right? So, so let's go ahead and run it, and it will walk you through all the things. So it's uploading image to ECR right now.
So we built the image before we ran it locally. So now it's just taking the built image and pushing it to ECR, right?
Yeah.
Perfect. And this is, when we say locally, we're talking about our Cloud9 instance, right?
This is locally is Jupyter Notebook environment, which is pretty much everything in memory.
Is that everything? Is that running on the EKS cluster?
Yeah,
okay.
As a pod. Yeah.
Yeah. Okay.
Yeah. So if you see, we've got ECR image repository that is created here. And that's the image that it's pushing. So it's 7DC, that's the image tag. Actually, it's done. That was quick. Yeah, so that was the image tag. So it's a very simple chapter. It quickly shows you how you can use fairing in order to capture the work that you've done on Jupyter Notebook and push it as a ECR image. So we're actually done with this one. We can close this. We can go to the next one.
Yeah.
And is it fair to say that fairing kind of takes some of the, I guess, heavy lifting out of my work, right? So I just write my algorithm, and I'm going to use fairing to help kind of stitch all of the other components together, deploying the algorithm and all these other pieces. Is that right?
Yeah, think of fairing. What fairing is doing is it's packaging the work that you've done, right? Like Docker Compose, it captures all of the work and then pushes it into as a Docker container into a repository that you tell it to. So that's the work that it does.
Cool.
And it also has the ability to, once it's pushed to a repository, it also has the ability to deploy that as a model as well. So
cool.
It's fairly powerful. So with this one, we're going to use another notebook. So remember, there's several notebooks here. We just ran the introduction notebook. We can actually shut that down because we're done with that one. With the second one, we're going to use the end-to-end. And what this will do is it will show you the full power of fairing, which is you build a model. You capture all the work as a container image, push it out to a repository. Once that's pushed to a repository, then you push it as a model, as a machine learning model. And then I think inference as well. So we'll take a look at the end of all of that capability. So with this one, we are using a different algorithm. We use XGBoost, and there is Kaggle computation on there's a link here on folks who have written this algorithm. So feel free to check that out. This was essentially to solve a problem of, how do you determine a housing price? How do you determine if you're going to buy a house or not? What are the parameters that you're going to look at? It could be housing price, it could be the neighborhood, it could be school, all of those things. That's what it does. So what we'll do is we can review here. We're going to run this notebook, which is end to end. And then let's just go ahead and run the cells, and we'll come back here to see how we are progressing. So this first cell is basically capturing the requirements file. Now we're going to do the installation. And I'm going to show you, as it's doing the installation here, I'll show you what I meant by the custom image that we built right earlier. See here, it says requirement already satisfied because we've already installed NumPy into the Docker container image, which is being used by this notebook server. XGBoost is already installed, right? So we've already installed these particular versions, so that's why it's saying, okay, this is already there. Let me move on and do the ones that is not available. And it looks like it's finished. Now we can go to the next cell. And that one ran fine as well. So here we're basically importing a few more libraries. Now we're going to run the algorithm itself, or store it in memory. Okay. And here is where we're going to actually train the model. So this class, housing serve class, and the train class, so that's what we ran. And the expected output is to show the mean absolute error, and the model exports. It exports a file called trained AMS underscore model.dat, right? So that's the model that it just built. And this was the outcome that we were expected to see, right? When it shows right here. I'm guessing you guys are still following me?
Yes.
Okay.
Sorry.
And no worries. You can see the file right here. That's the model.
I forget that you're not looking at us.
Yep. Cool. So that was a model that just got created. Now we're going to, let's see, we're going to create an S3 bucket to store pipeline data. And then we're going to run our training job. Okay. So for this, it says be sure to change a hash variable. Actually, this is already automated, so you don't have to do anything here. Just run, because we put a randomized way of creating a hash. So if you just run this, I'm going to minimize this. I don't know why we've given 16 here, but you'll see what I mean once I run this.
What are you changing it to? 3?
Yeah, just change it to 3.
Okay.
All right. So this is why, or else it will get like a 32 huge string. For me, this is random enough. 3 letters and 3 numbers. Is this too small? Can you make it bigger?
No complaints yet.
Yeah, Twitch, tell us if the font is too small.
Okay.
It's tiny for me, but I have a tiny screen, so that's nothing I can do about that.
Yep. So we created a bucket. Now what we will do is we will use fairing in order to train and push the container image. So let's run the next cell. Okay, so that worked. We'll do the next one. So it's simply, basically what we're doing is we're using fairing APIs in order to talk to S3 in order to talk to ECR, right? Docker registry. And here is where we're going to import the training job. And there is a there is a data set that we've stored in the image itself, so that's the data set that we're going to input, you use as an input.
And I see it says a remote, we're training it remotely. So I think this is one of the benefits of Fairing is you can take advantage of hybrid scenarios, right? Fairing can help kind of stitch those components together. Is that fair to say?
Yeah. Yeah, you can run it locally, which means you're going to run it on your Jupyter notebook itself. But if you decide to run it remote, which is, in our case, local is remote for us because we're just using Kubernetes in the cloud. But you can see here, what it's doing is it's deploying a pod, right? It's deploying a job, and then it will deploy a pod. So you can actually go here, get jobs, and do -EKSWorkshop. And that's a builder, right? So what Fairing Builder will do is it will take all the things that you specified in your requirements, in all the data that we supplied, and then creates a Docker container image. So if we do kubectl get pods, you should see so we should see that builder is doing exactly that, which is creating an image right now, or training the model right now.
Nice.
So it's downloading the files. It's collecting XGBoost. Now it's going to use XGBoost in order to train the model.
So arrow near one, I think he's clarifying. So basically just compiles the notebook into, so Fairing basically just compiles the notebook into a container image, right? And yes. So, but before Fairing, you would basically have to do that all yourself, and it was, well, a bit of a hassle. So, having it all right here and, building the image for you helps out quite a bit.
Yep. And you can see the steps that it's doing here. You copy the app. It's like a Docker file, right? So, you've got everything in your Docker file, and then when you run Docker run or compose, that's when the whole thing gets compiled and your container gets created, right? So that's essentially what it's trying to do. And now it's running a Fairing job, which is where now it's going to go and train the model. So now we should see 2 pods if you run this.
And NetHole's asking, am I missing why having a container would be better than an endpoint? And I think I can maybe answer that. Peter, tell me if I get it wrong, though. Having the container is what would help you have an endpoint. So right now, if you were to build everything and you were to build it locally, then your endpoint would be running locally. But if you want to, push that up to the cloud somewhere and have your model and it's trained in its trained state, able to run and produce an endpoint, then having it as a container is going to help with that portability.
Yeah. So another use case that you can think of is maybe you have a sample data set on your laptop, right? And your laptop can only handle certain horsepower. So, when you run it locally, like we did earlier, you can use that sample data set, test if your algorithm works. And then once you're comfortable, then you can, use the remote method, which is what we just did, right? And we are saying, and at this time, you can also specify a public data set or your production data set, right? You can make those modifications in your code and then run this remotely in the cloud so that you get, the enormous compute power and run it against the real data set.
And so could we talk about that for a minute? So from a production, development standpoint, how am I, as someone who's, responsible for managing a cluster and ensuring that, like I have CI/CD pipelines for my microservices. So I have controls in place there. How do I control that in this environment to ensure that someone doesn't just deploy a model that's broken to production?
You bring up a really good gap that is available in Fairing. So Fairing doesn't have any controls like that, right? So you do want to be cautious. So use this strictly for development purpose. And the Kubeflow community is working on providing that CI/CD capability. There are ways to automate your CI/CD pipeline where you can, once we take a look at Kubeflow pipeline on Monday, hopefully next week, there are ways to reproduce it and have it defined as a DAG or as infrastructure as code, where you just go and say, hey, Kubeflow pipeline, go and run this on a consistent basis so that your model keeps generating based on the new data set. So Kubeflow community is also looking at improving that process, but there is a way to do that today using KFP client as well.
Got it. Cool. That's just good advice and a good way to look at it. That just be careful.
Yep. Yeah. So this is what it spits out, right? So which is what we saw earlier when we ran locally, right? It created a model and then it gave the mean absolute error. So this shows you're getting the same outputs. Now what we can do is we can deploy this trained model. Now we can go and expose this model as an inference endpoint. So let's go ahead and do that. So this is the has no attribute items.
Excellent. So that means it's not items.
No, we're just hitting some kind of an error.
Dictionary, huh? So items is so you can iterate over items in a dictionary. Where are we calling items? Ooh, this is fun. I like a little roadblock here. Let's work through it.
Yeah. So we hit a snag here. Let me take a look. So we hit an attribute error.
Yeah, let's see maybe we can print. Is it input files?
And it's complaining about this particular object, Kubeflow AWS backend. Object doesn't have an attribute called items. So
right. So it's not returning a dictionary like we expect.
Yeah.
And this, by the way, someone in chat said I look like a game streamer, a famous game streamer. I was trying to figure out why, and I just realized right now because this particular gaming streamer sits up like really close like this when he's gaming, and so I now get it. So AJ nice. Potato, I get it. Why you said that.
Nice.
Okay.
Yeah, I think we're hitting this because with this one we are using the latest Kubeflow, Fairing version. And there might be some dependencies that is not solved. So let me see where we're installing Fairing.
So Kubeflow probably empty. What's setting that? Yeah, so whatever we're looking for, it's probably returning a none object. None type, I mean.
Okay, so I think we're getting this. This is the error where we're hitting it.
So what we could do is we could, just to confirm, we could run a print on Fairing backend and then just confirm if there's any data in Fairing backend.
Yeah, let me do, what I will do is I'll go ahead and do pip show Fairing. I think that was the command that we used earlier, right?
Oh, interesting. From NetHole, basically saying latest on a number of ML images have been hit by, excuse me, changes in upstream. that past couple of weeks, it looks like have caused some problems. So maybe you hit another one. Well, that's interesting.
Yeah, it's possible.
And you had even mentioned that, I think, earlier, Peter, that some of these images have changed, and even in the workshop, we've had to make some tweaks.
Yeah,
So.
yeah, we had to make some tweaks. So I think the snag we're hitting is because it's the latest version of Kubeflow fairing, and when we built this, it was using an older version. So what I'm going to do is I'm going to install the older version.
Nice. And with what NetHole was saying, what's one thing we say on this show all the time, Brent? Don't point to latest. And we're doing it live. That's true. Both things we say on the show all the time.
That's right. Don't use latest. Thank you. I can't believe I missed that, because that is like my sermon. So
yes,
man,
it's true. Like, definitely don't rely on latest.
Yep. Green Knight gets it right. Sort of can never rely on latest.
Green Knight does correct.
He does correct himself. But yeah, that's kind of funny.
All right, let me get on. I need to check if that was the version that we used. So let me just check real quick.
Yeah, Amazon Chime. What is that?
I know. I've all but deleted it.
Yeah,
it's already gone.
Okay. Huh? So up to this point, I think maybe let's talk about what we've done with fairing,
and then what we plan to do on Monday.
Yes, which, by the way, Monday, I'm saddened to tell everyone I will be off next week, so you won't see this pretty face for a full week. But I will be back the next week, rest assured.
You send me a photo. I'll just have you superimposed in a box up top.
That's awesome, actually. Have you seen those? It's one of these late night shows where they take a face, but they put lips. They transpose someone else's lips talking on it. We should do that. That would be amazing.
Yeah.
But yeah.
Okay. All right. So I think it's let's try this version. So it's 073. I'm hoping this is going to work. We'll see. It's just an older version of fairing that we need to use.
So Green Knight wants to know, does Kubeflow have any support for R?
Yeah, you can use R. So it's a Jupyter Notebook, right? So Jupyter Notebook comes default with Python. That is, I think, it's the most prominent language that is used. But yeah, you can use R libraries. You can install R libraries on Jupyter Notebook and write R as well.
Nice. And NetHole said it's in the ML certification exams to just rub your nose in it, but I don't know what he's referring to anymore. We may have lost track of that context in the video.
My guess is latest, pointing to latest image.
Oh,
That's my guess.
Oh man, yeah. I'm not surprised.
Yeah.
I've actually had to correct that, in a lot of places.
Yeah. Like, I totally get it when you're testing locally, right? It makes sense. You just want to keep iterating on the latest image because you got it locally. But man, if you fail in production pointing to latest, trying to find where you went wrong, that's not fun.
To me, that's as bad as like letting a TLS certificate expire. Like, that should just be part of your pipeline, is to look for the word latest and fail.
Yeah.
So.
Yeah, just don't do it. Friends don't let friends deploy latest.
I like
exactly.
So that's going to be the tagline.
And Pavan's going to miss you, by the way.
But the good news is, I think Pavan will be taking my place, and another pretty face will be here to represent.
It's really sorry, not sorry, because he's like, he gets to jump into the stream now. So,
yes. But yeah, listen, Pavan's been busy with moving, across the globe. So
he's been trying to adopt a new accent. He's been trying to, pick up that Texas drawl as quickly as possible. We'll see how
I'll come back now.
Exactly.
So it looks like we've been hit with the demo gods
striking
us. Yeah, that's okay.
Yeah, so what I tried to do here while we were speaking is I installed the older version of Fairing. So we hit an error over here, right, with Kubeflow AWS backend. And I installed the older version of Fairing somewhere down here, which is this guy. And then whenever you do the installation, you have to restart the kernel for some reason. That's how Jupyter Notebook works.
Yeah.
So I did that, and then I was running the cells again, but looks like I'm hitting some other issue here. So we may have to come back to you folks for this particular notebook. So it looks like this one has some issues. So I'm gonna work on this, and then we can try to solve it in the next session.
Perfect. We'll get that worked out. And really, like, how important is that that we could move on, I assume. Not that we have time to move on today. We should probably go ahead and bring back the couch and all that good stuff. So and close out and talk about what we did this week and what we are going to be doing next week. Yeah, sorry about that. That was kind of a surprise.
Yes.
So we started out the week actually talking security and things like that, but then we had some questions about machine learning and Kubeflow, so we jumped in and snagged Peter and wanted to get some expert representation in here on running Kubeflow on EKS, and it's been great. We've learned how to install it. We've learned how to train a model. Now we've learned how to use Kubeflow Fairing. So we're going to continue with that next week. On Monday, Peter's going to be back, and we're going to get into hopefully more of the Fairing chapter, but then also we're going to take a look at pipelines, and we're going to see how far through that we can get and learn about automating our machine learning. So then after that, Pavan is going to be joining us, and we're going to be getting back to talking about security. And it's going to be with a focus on Kubernetes, and we're going to take a look at some new stuff that AWS has announced and released, and just other good security practices. So definitely join us next week. And Adam, you have anything to say before you're gone forever?
Forever for a week? Are you replacing me, Brent? No, but honestly, Pavan is good. Like, when it comes to security and Kubernetes, Pavan is the person you want to hear from. And I'm excited to see that, because I think it's going to be some really good in-depth discussions. And by the way, these are topics that come up from our viewers. So if there's anything you want to hear us talk about, shoot us a DM on Twitter, say it in the chat, whatever. Wherever you want to message us, reach out to us. But we want to make sure that we're tailoring content to fit what you guys want to hear about.
Exactly. And all of this we're going to be embedding into the workshop, and we're also adding it to our YouTube playlist. So you'll have access to this forever, maybe. We'll see. But certainly as long as it's relevant. So join us. Again, won't be here tomorrow. Come back Monday, noon Pacific, 3 o'clock Eastern, and we're going to continue with Kubeflow. And until then, you guys have a good weekend.